equals the square root, plus minus the square root of 5I over 2. So those are your x's. In order to find your y's, you're going to take those and plug them right up there, back into this y equals. So let's start with the easy ones. So you have 1, so that's 1 squared is 1 times 2 is 2. So you have 1 comma 2. Plug in negative 1, you get negative 1 squared is 1 times 2 is 2. So negative 1, 2. Now, when you plug in this portion, we really don't want to plug that in. If we go back up here to what x squared equaled, we can plug that in. So you have 2, x squared was negative 5 over 4 equaled y. So y is negative 5 over 2. So then you have plus minus radical 5I over 2 comma negative 5 over 2. So you have 1, 2, 3, 4 solutions on that one. Number 5, z varies directly when, z varies directly with x and inversely with y. So z equals k, directly means multiply, inversely means divide, okay? And it says z is 121 when x is 6 and y is 5. Okay, so we need to solve this for k. We'll multiply by 5, divide by 6. So you have 121 times 5 divided by 6. Let's get a fraction. So k is 605 over 6. It also says, what is z? So z equals when x is 31 and y is 7. So 605 over 6 times 31 over 7. So we'll just put that in the calculator. So times 31 divided by 7, and it says round to the nearest hundredth. So that's 446.55 would be your answer for that. Okay, number 6 says determine if odd or even or neither. So if I were to put in negative x and get back f of x, that is even. If I put in negative x and get out the complete opposite, that is odd. Okay, if I put in negative x and get back neither odd or even, the saber. If I neither get back the same or opposite, it's neither. So if we look at the first one, I'll plug in negative x. I'll reduce it, so this becomes 2x squared plus 3x plus 1. Okay, so that is neither all the opposite nor all the same, so this is neither. And if we look at the second one and reduce it, I get x squared plus 1. Now this is the exact same, thus that function would be even. Okay, I'll do this one kind of on the paper here. It says tell when increasing, decreasing, constant, when the function is bigger than equal to 0 and less than 0. So increasing. Okay, so I'm just reading it left to right, and I want to know when is my graph going up. So kind of put some numbers on here. So it's increasing from -4 to -2. Union, let's see, 1, 2, 3, 4, 5. So 6 to infinity. Decreasing to when is it going down from negative infinity. And even though it changes directions here, it still goes decreasing there. So that's -4. Union 1 to 6. When is it constant? That would be from -2 to 1. Now notice here I could go from -infinity to -4, -4 to -2, -2 to 1, 1 to 6, 6 to infinity. So I've covered all my x numbers there. So f of x greater than equal to 0. So that is, when is it above the x-axis? Okay, so 4, 5, maybe 5.5, -5.5. Oop. That is -infinity to -5.5 union maybe 2.5 or 2.75 to 5, -2.75 to 5, and then 6.5 to infinity. And then when is it less than equal to 0? So when is it below the x-axis? So we're using the same numbers. So 4, 5, 6.5. Wait, that's 4, 5, 5.5. -5.5 to -2.75 union 5 to 6.5. Okay, it's these two holes right here. Okay. And that's all you're doing. You're just trying to find intervals for all that kind of stuff. Okay, so now we have a word problem here. And it says you buy a 5-acre lot that is about 200,000 square feet in a rectangle shape. You're going to fence the entire property and divide the parcel into 2 halves with a fence. If 2,200 feet of fence is required, what are the lot dimensions? Okay, so you have this lot that's rectangular. You have a length and a width, and you're going to divide it in half again. So the total area, which is length times width, is 200,000 square feet. I have 2,200 feet of fence. So that's the perimeter or the length of all these sides. So that's 2L plus 3W, since I got that middle section, is going to total my 2,200 feet. So we're going to solve this system of nonlinear equations. So we'll take this and we'll solve it for L maybe. So 200,000 over W. We'll take that and plug it into the bottom. So you have 200,000 over W plus 3W equals 2,200. So that's, I want to get rid of my W at the same time. So we'll multiply the whole thing by W and kind of rearrange this equation. So you have 400,000, your W cancels, plus, we'll put that up front, 3W squared, because W times W. And we'll move this over, minus 2,200 W equals 0. So this is a quadratic. So 3W squared minus 2,200 W plus 400,000 equals 0. We can solve using a quadratic equation. So W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So that's 2,200 plus minus 200. Okay, so you got 2,200 plus 200 divided by 6 is 400. You have 2,200 minus 200 divided by 6. Which is 333 1/3, or 1,000 over 3. Okay, so now we'll take that and we will plug it back in to one of these equations. So we'll probably just plug it in right here. So you have 220,000 divided by 400. So you have 400 by 500, or 220,000 divided by 1,000 over 3. So that's 1,000 over 3 by 600. Okay, and we can definitely check these solutions. They should both maybe work, but the first thing we want to do is multiply them together. So I'm just plugging them back into these two equations. So 400 times 500 is the right answer. 1,000 thirds times 600 is the correct answer. And then 2 times 500 plus 3 times 400, 2,200. And then you have 2 times 600 plus 3 times 1,000 thirds. And that works. So we do get two different types of solutions for that fencing. Okay. So number 9 is all matrices. All right. And I think what I'll do is I'll make this question maybe worth 5 points. Each one is 1 point apiece. And I don't need to see work, so I just need your answer here. So the first thing I want is C times D. So that's multiplying these two together. So we want to just put it in the calculator. So go to matrix, go over to edit, and C, or I'll just put in all of them here. So A is a 3 by 3. That's 1, -1, 5, 4, 2, 4, 5, 3, 1. B is a 1 by 3. 1, 2, 3. C is a 3 by 3. D is a 3 by 1. And E is a 2 by 2. Okay, so I want C times D. So go to matrix, C, matrix, D. So there we get 6 minus 1, 23. There's our answer. Then we want 2. So 2 times A. So matrix A minus matrix C. So there we go. 0 minus 3, 9, 8, 5, 8, 7, 8 minus 3. Okay, and then this one here, we have -1 E squared. 5, -12, 8, -19. And D is B plus D. So B plus D. Okay, it says right here, error, dimension mismatch. Well, if I look here, B is a 1 by 3 and D is a 3 by 1. So since those aren't the same, you can't add. So can't add, dimension mismatch. Okay, and that's it. When you are finished, we want to clear all the matrices out. So you'll hit second plus. It'll pull up your memory screen. You want to go to memory management, which is number 2. You want to go down to number 5, which is matrix. And here's all your matrices. So we'll just hit the delete button until they're all gone. And then you're done. So if I go to matrix, they are all cleared out. Okay, don't trust any matrices that are already in there. You want to make sure you put your own in. Okay, number 10. We'll have y greater than or equal to x squared minus 2, x squared plus y squared less than or equal to 4, and y is less than or equal to x. Okay, so we're going to graph these out. Okay, the first one is a parabola that opens up and is moved down 2. So 1, 2. We have a solid line because it's equal to. Don't forget to plot some extra points. Okay, and y is greater than your parabola, so you will be shading on the inside here. Okay, the next one is a circle centered at 0, 0 with radius 2. So 2, 2, 2, and 2. Circle. Your circle is less than your radius, so we're going to shade on the inside. And then you have y is less than or equal to x, which is this diagonal line right here, solid, and y is less than that, so we will shade below. And your solutions come from right here. That's your solution set. So any numbers in there. So I might say, graph this and name one solution that works. So we might name 0, -1 will work. Okay, a parabolic arch reaches a height of 40 feet at the center. The base of the arch is 30 feet wide. You want to drive your RV through it that is 14 feet tall and 8 feet wide. Will you make it? All right, so I have this parabola. We'll center it kind of on the origin here. Okay, it's 40 feet tall. So this point right here is 0, 40. It is 15 feet wide. Sorry, it's 30 feet wide. So that's 15 this way and 15 this way. So this is 15, 0, and this is -15, 0. Okay, and I'm going to drive my RV in it. That is 8 feet wide. That's 4 here, and 14 feet tall. I don't know, will it make it? Will it not? Well, the first thing I need to do is find the equation for this parabola. So parabolas are y equals ax minus h squared plus k. H and k are the vertex. Well, my vertex is 0, 4. So that's 0 on the h, so that goes away, and 40 on the k. So y equals ax squared plus 40. Now I need to know what a is. Well, I have an x and y ordered pair on my graph. That's either this one or this one. So we'll plug it in. So 0 equals a 15 squared plus 40. So then we solve for a. And you will get a fraction that is -8/45. Okay, so the equation for your parabola is y equals negative 8 over 45 x squared plus plus 40. Now, I want to know where is the corner of my RV compared to this line right here. So I know it goes 4 out. So this is 4 something. Okay, so I'm going to plug in 4 here and see where my parabola is. So y equals negative 8 over 45, 4 squared plus 40. So we'll kind of plot that, or we'll put that in the calculator here. So negative 8 over 45, 4 squared plus 40. So y is 37.16 feet. So this is telling me that this parabola at 4 is, this one is 414, is 437.16. Okay, so if this is only going 14 feet high, but my arch there is 37 feet high, then I will for sure make it through the tunnel. A satellite dish measures 10 feet across its opening and 2 feet deep at its center. Where should the receiver be placed, and what's the equation that governs the shape of the dish? Okay, so I got a dish here. I'll just center it at 0, 0. We're 10 feet across. So it's 5 feet. 5 feet. And this right here is 2 feet. Okay, and I want to know, where is my receiver going to be placed? Sorry. So if I'm going to open this way, we need the equation. So that is y squared 4px. Okay, so the center is at 0, 0. I also need to find where the receiver is going. I know that this point right here is 2, 5. So that's how I'm going to find my p-value. So I'm going to plug in 5 squared equals 4p times 2. So it's 25 equals 8p. So p is 25 over 8. Okay, so now my equation is y squared equals 25 over 2x. So that's the equation that governs the satellite. Okay, and we're going to use that to find the focus. The focus in this case is p comma 0. I'm just using that worksheet I gave you, or that handout I gave you, to find that. So your focus is 25 over 8 comma 0. So that's where the receiver needs to be placed, somewhere in there. Sorry, that's somewhere out here. It's like 3.125, not there. Okay, somewhere outside of that satellite dish. Okay, an elliptical trainer has a stride length of 16 inches. The max step height is 12.5 inches, while the minimum stride height is 2.5 inches. Find the equation of the elliptical centered at the origin. Approximate the distance the elliptical travels in 1 revolution. How many steps are needed to travel in 1 mile? Okay, so here's my elliptical. And the stride length is 16 inches. So if I center this up, that is 8 inches over here and 8 inches over there. From the ground, the stride height changes from 12.5 to 2.5. That's a total difference of 10. So that's 5 here and 5 there. So my equation will be x squared over 64, which state squared, plus y squared over 25, which is the b part, equals 1. So there's your equation. It says approximate the distance the elliptical travels in one revolution. So you need the perimeter of this. The perimeter is estimated by this equation. Okay, so we'll just put in a and b squared, which are these two numbers. So you get pi radical 2 times 89. So then we'll get we get 41.91, which is about 42 inches. And then it says how many steps are needed to travel 1 mile. Well, a step only covers 16 inches. And you have 5,280 feet in 1 mile. Well, I'm going to change this feet to inches, so multiply by 12. You get 6360. If I divide that by my 16 inches, I'll get 3,960 steps. Okay, don't confuse this pattern. Okay, this is just the distance your foot is traveling. This is the actual step length. Okay, that's 1 foot in front of the other. Okay, a radar tower is located at 0, 0 and spots an object 160 miles away. Or 106 miles away. So here's kind of my grid here. 0, 0, my object is 106 miles away. Okay, 74 miles east of Tower A is Tower B. So this is A, this is B, which spots the object. So all that was 74, which spots the object 66 miles away. What is the equation of the hyperbolic path of the object, and what two possible coordinates of the object's location? Okay, so my hyperbolic path is there and there. The distance, so we have the center. The difference between these two distances is 40. So that means this from here to here is 40, or right here is 20. Okay, the center of this, okay, 70, which would be half of 74, which is 37, 0. So we have x minus 37 squared over 20 squared minus y squared, because I don't go up and down any, over b. Now, b is the distance from your foci, or sorry, from here to your asymptote, okay? But I already have A and C. C is from here to here, which was the 37. So A is 20, B we don't know, C is 37. So that's 20, whoop, you can't see any of this. So 20 squared plus b squared equals 37 squared. Okay, so 37 squared minus 20 squared. So b squared is 969, and the square root of that is some decimal. Okay, so we're going to take that. This is 969 equals 1. So here's our equation, x minus 37 squared over 400 minus y squared over 969 equals 1. There's your equation. And this is where the two possible locations for this object. So it's either up here